Welcome back. Poor people who thought the streams were over and they left. And now here I am doing it again. Targeting the nighttime crowd this time. Where is my mouse cursor? Why can I not see it? There it is. Why does Twitch think I'm offline? There it is. Twitch thinks I have no viewers. And there is nobody in chat. Have I done something wrong? Streaming? I can see myself streaming. Oh, there it now shows 27 viewers. Okay. It's just taking a little while to go. So I was done with the stream, but then I kept wanting to try. I kept thinking about it. And as I said, I don't want to work on this code base off stream. So if I want to work on it, I kind of have to stream. And so, you know, people who aren't around to see it can watch the archive. That's fine. And, you know, we let the nighttime crowd get a chance to see some of it. So, so where we left things a little bit ago, I wrote a new measure. It does not yet preserve the textures that are requested, so it's just putting random textures or a simple pattern up. And you can see that the old measure ran in whatever it was, 10 milliseconds, 20 milliseconds. And then this version went down to 10, and now it's down to 0.48 milliseconds. I was talking about the fact that if our budget is like 1 millisecond per frame, and we're not really drawing that much here, then that's going to be a problem if it actually takes a millisecond. But I'm not doing things the fastest way here, so we're going to see what we can get it down to if we make it smarter. So, so what we've done is we've built a bit array in shared memory representing occupancy. And then in here, we read from that bit array and compute the voxels and generate them directly. And this is a placeholder for generating a list of visible voxels and applying that, then later the textures get applied to correctly, which is going to add even more time to the shader. But the thing about this is that the utilization is really bad because we iterate through the 32 possible voxels, and only some of the time is this running, and it's totally different on each thread. So maybe that's a source of slowdown. So we're going to try to make the occupancy or utilization higher, and we have a strategy for that over here. So we're going to build a new set of job lists from this job list. So we go to our job storage. And we're going to double it. And this is just an arbitrary guess at kind of a bound on how many voxels you can have, where you could probably make it a lot smaller. We could also be being limited. Let's actually do this check first. So we can try reducing how much voxel data we process and see, do we get a speed up, a proportional speed up. Yeah, you can't define it twice. Yeah, we do see it speed up by like a factor of 3. So one thing we can do is we can bring this down to 512, and that'll give us some speed back. Another thing we can do is we could try to do fit more jobs in shared memory by doing this in 2 steps, doing the first 512 and then doing the second 512. But obviously that's not going to be any faster than just doing, well, the top one will probably be sparser, but it would still probably be double this, so that's probably not going to help. But like we would expect that this is going to get slow as we use up too much shared memory. Oh, I did that again. Like here, if I just waste some shared memory, cannot locate suitable resource to bind variable occupancy bit array, possibly large. So that went up to 0.53 from 0.41. So if we waste some memory, right, we get to run fewer jobs, get less overlap, and so this does become a critical resource. Is it a critical resource now? Hard to know. Because if I make it smaller, we're actually then doing less work too. So, so that's a thing we can do. Another thing we can do if our budget is too high is, instead of using chunks that are 256 by 256, we could use chunks that are 128 by 128. And then take more frames to process them effectively. Effectively, still use 256 by 256 chunks, but process them over 4 frames, a quarter of it at a time, and then, you know, that would take 1/4 of the speed, and that may limit our movement rate is the problem, because now you know, the further you move, the more chunks you need to generate. The faster you move, the more chunks you have to generate per second. But we do have this strategy, multiple job lists, and how do we wait, why are the job lists so big? The job list should only be, why is the job list 655 through 64K? That was the different job list. That was for, these are word jobs. Okay, so the word job, there's only 32 word jobs. There's only 32 by 32 by 4 bytes. So wait, which one is the word job storage? Binding equals 6. Here, 6 job storage. Yeah, so job storage doesn't need to be that big. Job storage is 32 by 32 by 4. No, wait. Job storage. God, I'm so confused. Times 32. Word job storage up to 32. So it's 32 by 32 by 32 times 4. Well, wait. No. No, because it's per column. Every column can generate up to 32 jobs. Okay, I'm totally lost. It's still the math here was wrong. Job storage. Base is... This doesn't seem right either. Max jobs is 256 by 256 by 32 jobs equals 2 to the 8 times 2 to the 8 times 2 to the 5 times 2 squared bytes equals 2 to the 16, 23. So, and then the spacing between them should be 32. No. Spacing between them should be... Oh, I see. So the way I tried to do the math before is per work group. Okay. Jobs per work group is 8 by 8 by 32 equals... And yeah, this math was from when the jobs were a different thing. So this is 64 times 32, or 2,048 jobs per work group. So then there are 32 times 32 jobs, 32 by 32 work groups, times 2,048 jobs times 8 lists, let's say. Let's make a separate one. Times 32 times 2048 times 8 jobs. So this is 2 to the 10. This is 2 megabytes. And so this would be 16 megabytes. So then base is the work group index times 2048. Okay, and it still works? No, did not still work. Did not have enough storage, clearly. Did I forget to multiply by 4 bytes per job? Job storage is 32 by 32 work groups, 2488 jobs per thing, times 4. 8 megabytes. 64 megabytes. Okay, good. Now, each work group we need to merge across the work groups though. maybe not. Let's just try it and see what happens. So at this point, we've built our first set of work groups. Atomic ended to append index. So now we have shared, we got rid of consumer index, shared int split job index, and there are up to 8 lists. If lane y equals 0, split job index of lane x equals 0. Initialize it to 0. And then generate or make split jobs we ended up not using this after all. So we do this same logic. And now we repeat the same computation once again, like that. All the lanes are doing the same work. But now we don't want to iterate over voxels because that's varying per lane. So instead, we're going to output a split job. And so the way that's going to work is like this. But we don't need to repack the job. We can just use the job we have. Atomic add of split job index of split. We need base. Yeah, we can use the same base. No, it needs to now get multiplied by 8. Split base is base times 8. Outbase equals split base plus split times 2048. Doing the 3D math manually, and then that goes to outbase plus slop. So now we just have to say if voxels equals 1, voxels equals 0, continue, voxels equals 1, split equals 1, voxels equals 2, split equals 2, voxels. So we want to make this table driven probably, right? count equals voxels equals 0. Continue. Or actually, let's just do voxels greater than 0. And if put that here. So the split is split for count of voxels minus 1. And this will be 0, 1, 2, 2, 3, 3, 4, 4, 4, 4. Maybe that. Let's make a copy of generate visibility. And call it generate visibility old. And then this becomes if one generate visibility old, else make split jobs. How did I spell that? Split jobs. Split jobs. Generate visibility. So we had this list of all of the voxel clusters, 32 voxels, that at least one of them was visible. And we go through that list, compute how many are actually visible, and now split them out into multiple lists that have different numbers of visible ones. Then when we pull from the lists, we'll be more coherent. However, we probably can't keep these lists. We probably need to go merge these lists across neighboring. But then they can't answer. Yeah, we'll have to see. No, you can't do that because then they can't access the visibility. I guess the job could store the visibility. So then it could be processed in a separate pass. I guess that's possible. All right, well, we'll see. So at this point, we've split the jobs. Each one got its own index. So now, for I goes to 0, are we using I down here? Here we are. Let's use J. So we go through the lists. List less than 7. Count equals split for count of list. Then the base computation we need to update. So the out base computation. Split base is base times 8. This is now out base plus input slot. We compute this yet again, but now we expect some coherency. Oh, but we need to use the find LSB thing. This isn't going to be any more coherent. Well, all right, we'll just do it by hand. Okay, well, let's just leave it alone and get it working first. All right, first of all, does the old one still compile? Did we break it? We broke it. Oh, we consume index. We're still like initializing it or something. Yeah. Oh yes, streaming has succeeded in what Michael was. Syntax errors, that's just going to be a missing semicolon or something. Undefined value split. Split is now list. Split for count. Split for count. Split for count. Split for count. What? Well, I don't like it looking at an array anyway, so we're just going to say if voxels is less than less than or equal to 4, split equals voxels minus 1 if split equals 3, split equals 2. So that handles these 4 cases. Else split equals voxels shift right 3 plus 3. So like this is 8. 8 shift right 3 is 1 plus 3 is 4. Split for count. I just deleted split for count. Oh, there's another one. Oh, that's the wrong variable. Split for count, that should be split job index. Why do we not have a region? How did we lose region? Syntax error at 327. Missing curly brace somewhere. Right here. Just do that. Undefined base. That's now out base or something. Or no, we just lost base. Lost base and region. Okay. So this is just running the old code. And it's still correct. All right. So now we switch to running the new code. And it's wrong, unsurprisingly. let's always assign them to split 0. And only process split 0. Okay. That's weird. Like, we should just be copying the lists and then drawing them again. Wait, we didn't allocate enough memory? No, that would show up somehow different. So first, we go through the existing jobs, which is base, plus input slot. Compute the count. Voxels should always be greater than 0. We should never actually get here with the voxels less than 0. Split base plus split times 2048 plus slot. That uses split job index of split, which is always 0. So then we come in here and we say split job index is our limit. Yeah, it would help if we actually indented this loop. Right, we got a warning about that and I misinterpreted what the warning was. Okay. Better, but we're not correctly handling past the beginning, which sounds like not enough memory. Multiply this by 2 just to see. No, not that. This is still with split being forced to 0. So we really should just be copying the jobs over. That looks like a missing barrier. But I don't think there is one. Oh, this is supposed to go to split job storage. Actually allocate the memory for it. Or we allocate the memory, we just have to actually bind it. Split job storage. And then make split jobs reads from word job storage and writes to split job storage. And then this one reads from split job storage. Okay. So now we do the old path and we don't render, and we don't take that final step, we're already at 0.47 milliseconds. So just compute occupancy, I had forgotten that. So wait, how is this going to help if that's already at 0.47? I think I didn't realize it was. Because we're not speeding up this. No, this was used to only be 0.06. Okay. Compute occupancy alone used to be 0.06. So why is it not now? Did I miss? Why is it 0.047? Was I not counting this? No, it was counting. It's supposed to be this path. This is super slow, and we don't know why. And then this is fast, and it used to be 0.06, and now it's slowed down. Why has this gotten slower? I don't know. That's annoying. I guess they tried to pull it out of the version control and reconstruct it, but maybe I wrote down the wrong time. Maybe I wrote down the time when this whole thing was disabled. But if that's already, I feel like I'm missing something. If that's already 0.47, then when we turn this on, when we turn that on, shouldn't it get a lot slower? But it's only a little slower. So it's not even spending that much time in this function. Now, it used to be, but now it's somehow spending all the time up here. Oh, I'm so confused. Why is this slow again? Okay, if we don't do any of it, that's fine. If we do this, if we only do every other, still just as slow. If we say int slot equals gel local invocation index times 8. Is it the atomic? It's not the atomic. What? Vis bit array equals 1. That's fast because it optimizes this out. It's like it's also doing this, whatever the bug with this is. It's doing that again with this now. One ship left. GL local invocation index small 3. Fast. Let's loop 16 times. Still fast. Oh no, because that's this. Right. Still fast. What? Slow. Fast. Something really weird is going on here because this was the exact same place we had to slow down and tried to do the LSB stuff. Something really odd. Fast. Oh no, that's because this. Slow. Just doesn't make any sense. Same thing where the optimizer is screwing it up, but on a totally different time scale now. I guess. For lack of any better idea. Okay. Let's split it into 2 loops. And go, the first loop goes 16 to 32, and the second loop goes 0 to 16. And it has to actually enforce that. Maybe it's unrolling these. Maybe it's unrolling the loop and it's super inefficient to do it. NVIDIA GLSL disable unroll. That's a CUDA thing, I think. Well, we'll try it. The AI is giving me an answer, and I don't see an answer otherwise. Pragma unroll 1. Pragma unroll 32. Yeah, I don't know if that's actually true. Pragma unroll. This is from 10 years ago. Pragma unroll 1, and then pragma unroll 0 to restore the old behavior, I think. That's actually what it says to do. But yeah, that's so weird. Is bit array equals 0. It's 55555555. Oh no, I gotta do that before count. Okay, now it's constant. Let's just do 3. And yeah, it's fast. If it's 0x33, still fast. 383, still fast. A little bit slower. Okay. So if I hardcode a constant, it's unrolling it and it's just faster. Yeah. What we'd like to do is increase the utilization by having them all do it at the same time, which you do with this. We say I equals find LSB is bit array, and then we say while I is greater than or equals 0, do this work. Less than 32. Now we find the next I while I is less than 32 and is bit array and when you shift left I equals 0 plus I. Let's call this X. Avoid confusing the optimizer when it's the same, when it's a different variable. not X, M. Okay, this is a terribly inefficient way to do it, but we'll just to see if we get different results. 28. Reset the driver, which moved everything onto the same monitor. So we gotta move all of my windows before I bring this back up. But I know I need to bring it back up, don't worry. That one we don't need. That one goes over here. 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 Oh, except I'm pushing them too far over. Oh, right, because I need to restart OBS. Right, but I don't want to do that until I've done all these. Oh. Yeah, okay. Yeah. So then bring that back up. Restart OBS. Oh, right, I have to actually redo the projector. There we go. Okay, so this did an infinite loop. We have to always increase M by 1. (15 milliseconds). So that's super inefficient. But it is doing the find LSB. So let's manually find the LSB. If M is less than 32, let me do this. Is that always going to increment M? If M is equals that's this one. Still slow. So it's possible to find LSB is doing something like this instead of being run in parallel. So yeah, I don't know why this is now slower than it used to be, but since it is, it makes this whole thing that I'm trying to do worthless, because now this is the part that's slow, not the other part. Okay, well, there is a way to find the lowest bit. What's the way to find the lowest set bit? Uint lowest set bit of uint of x is return x and x minus 1, I think. And so then we want the hacker's delight probably has a way. Hackers delight find LSB. Get index of the LSB. 266 entry lookup table. No. Where? Why do I not just get a hacker's delight? Oh, because I explicitly said that. Is there something equivalent to hacker's delight that's just online? Like, I wonder if there's some multiply that you can do to get. Wait, that. According to hacks delight, that turns off a 1 bit. Oh, it's twiddle. Yeah, it's that. Oh no, that's right. Most 0 bit. 1 bit. I guess you can XOR with the original, but there must be a cleaner formula. Oh, right. It's X and negative X. That's what it is. Okay, that gets you the low set bit. Now, bit index. We want some function that gives you the bit index. That has to be in here somewhere. I guess we can search for index. No, great. Position. Compute position of compute log 2 x of integer hack. Compute log 2 of single set bit integer. Yeah, yeah. I just was wondering if there's like a tricky multiply that can get it to you. Because that's too many. Having to do that many instructions is not going to be an efficient approach either, I don't think. But wait, we're only running this. Yeah, this just doesn't make any sense. We're only running this 32 by 32 by 32 times. No, 2v6 by 2v6 by 32 times. But even so, yeah, I don't know. I mean, the basic fact here is that it was that other time and now it's slow again. Maybe this is a factor of OBS messing with me. I mean, all right, I'm going to turn off the OBS projector just for a second and check the time with it off. How do I turn off the projector? Like that. It's still 0.47. Close OBS, run it down to 0.41. So OBS is pushing it up from 0.41 milliseconds to 0.47 milliseconds. But that's not going to push it from 0.06 to 0.48. So I'm just stuck here because the time just changed, unless I misreported it in the notes. But I don't think so, because that was part of me comparing very directly the LSB, find LSB approach versus not. And the problem is if I do a lot of work, it's still not that slow. So I don't see how. Okay, let's do this. Lane X and 1, 0. Then we do 1, 2, 3, 4, 1, 2, 3, 4. Otherwise we do 0x, C, 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 C. That we were using every iteration, one or the other of the lanes has to do it. Yeah, that's only 12. So somehow I mean, this could be getting optimized somehow, but like, how is it that... Oh, because now it's never computing this. If I... Yeah. Yeah, no, okay, that was all bogus. As soon as I set bit array to a constant, it's skipping all of this processing. So none of that is evidence of this. The problem is actually the performance up here, probably. Okay, so but how did this ever get to be 0.06? Oh, maybe I had viz bit array as a constant when I did that test. So and potentially it was culling everything. So how can we make this go faster? Let's reduce Z words. If we reduce Z words, then we still have to do the full loop over the command list, but we do less of this work. Okay. But then when we double it to 1024, it more than doubles. So maybe that is occupancy. So maybe we stick to 512. Let's make sure that 512 is. I think this thing only goes up to 240 or something. I think that's not gonna. Yeah, now with the old slow one, it's 0.16, which is not too bad. Get rid of this code. Expand on what you mean by you're doing it wrong and explain who is a lad. So now we can go back to splitting. So this was at 0.20. .06. Why is this suddenly slow? Why? Why is this slow? That's still slow. List only goes over 1. Let's make that explicit. I guess that was a drive-by. Why is this one slower than that one? It's because we do spend time in split jobs. So is that the cost of doing split jobs? No, it's not the cluster doing split jobs. It's the cluster doing generate visibility. But how is this one different? We only iterate this list once currently because we're debugging. So it shouldn't do anything different than the other one. Right? It should be almost identical to generate visibility old. What? God, I hate this. Generate visibility old. If we call make split jobs and then generate visibility old, but if we only call make split jobs, the stuff might be getting optimized out, so it's really hard to know. There's atomics in there that can't get optimized out, but maybe a lot of the other stuff can. This is only one job per input job. This ought to be fast. And this is doing the exact same work. We if zero this out. It's still slow with this if out. If we if this out, that'll just, it won't have to do anything anymore. So that'll just get optimized out. Or doesn't get optimized out, okay. No, not that time. It's not in the timeout. I'm so confused. Like this should optimize everything out. Just the cost of doing a barrier. It's just the cost of doing a barrier. Okay, wait. What does the barrier do? OpenGL GLSL barrier. Am I using the wrong barrier? Why is this? All invocations within a single workgroup. But we only have 2 subgroups per workgroup because we're doing 8 by 8. I don't understand. It doesn't wait for idle till all threads finish. There are 2 hyperthreads per workgroup, and it just needs to synchronize those 2 hyperthreads per workgroup, which shouldn't be. It doesn't synchronize across unrelated workgroups. Because the 32 of them are, there's 64 in the workgroup, and 32 of them are lockstep SIMD. So it just makes one block until the other one's done. Which seems weird to me that would... be that significant in overhead, since the other threads should be doing similar amounts of work. So it's doing a barrier after make split jobs that costs. The one ahead of it doesn't cost. Yeah, I mean, these are doing... I mean, that shouldn't make any difference. That would be a compiler bug if it did. Yeah, it's a little random. Yeah, it's this one. This doesn't even need to be indented. Alright, let's change the timeout. Make sure that's not being hit. I don't think so. Well, we could switch to only having 32 threads. And then we don't need the barrier because they're always in lockstep. It's just inefficient. I expect the occupancy to be worse because of the shared memory usage. If we get rid of the barrier, and then, I mean, maybe some optimization is going on here, and then we turn max Z back up. Oh, it goes all the way back up because of occupancy, probably. What? I mean, we can't not barrier, but we also barrier before it and it's fine. That's just weird. Why is the barrier before it fine, but the barrier after it is not fine? Because the barrier before it is after we're doing a similar work, writing out to Word job storage. Now this loop just basically copies Word job storage to split job storage and does a barrier. But this one hurts. Why? Are we doing more atomic adds in this one? Yeah, we do count up front. We are doing more atomic adds. Let's get rid of that so that it gets spread over more atomics. Wait, I thought I was at 0.45 before. How did I go back up to 10? Wasn't barrier putting me to 0.45 milliseconds? Right? Wasn't that where we were? It's that it was putting us at 0.45 milliseconds. And now it's putting me at 10. Did I leave some debugging in again? No. Oh, I didn't have the barrier at the end. I had it in, yeah, I had it down here. And so I was trying to figure out why generating visibility was costing so much. Yeah, that's probably right. Yeah, I was probably at that. And then I turned on generate visibility and was like, why is this so slow? And then it turned out it was the barrier. Crazy. Crazy, crazy, crazy. Should be voxels if voxels greater than 0. What happened to that? And then this is actually subtract 1 from voxels first to make this calculation correct. And then this is 3. Yeah, I don't know. It's 10 to 0.21 milliseconds because we reduced it from 1024 to 512, I think. Yeah. So even though this one takes a barrier, just trying to split the jobs into multiple separate loops and iterate over just one of them slows it down. It takes an extra barrier, but the other one's still taking multiple barriers. Right, generate visibility old takes a barrier here, and compute occupancy takes a barrier here. So we already have 2 barriers. So taking a third one, it seems weird that that would cause it to blow up when it's doing basically a constant amount of work inside. Assuming it schedules the 2 work groups together, the 2 subgroups together. Other unrelated work groups do not have the same amount of work, but they're not, the barrier is not synchronizing them. That's why it's weird that AMD and NVIDIA don't have a term for work group. All right, well, if we only run eight by 4, no, then we have to change the global invocation ID XY has to change. CTA for whom? What does CTA stand for? Compute thread array. Cooperative thread array. No, I think a CTA is just a warp, isn't it? Oh, no, okay. It is the group of warps, yeah. So CTA is in fact correct. So why is this barrier bad? This is amazingly fragile. I'm really surprised how hard this is. Like correctness, I understand, but the weird performance pitfalls are crazy. All right, where do we use global invocation? Maybe I can do this hack. We use it for pause, but then we subtract region. And that'll break. All right, so if we do this, if we make it only 32, then we don't need the barriers. But then the barrier should be a no-op. Oh, okay. It's slow even with that barrier. Possibly something is going wrong with the math and causes it to do something bad. Since it's not actually computing what I think it's computing. Since it's secretly altered behind its back. Maybe something else is going wrong somewhere here. No, is the atomics fighting? Do we zero the occupancy bit array? I don't think we do. Oh, we do here. Okay. Lane X and lane Y. Right, but now we're not doing it properly. Now we're not actually zeroing it. Oh, this isn't zero. How did any of this ever work? This must be relying on. This must be zeroing the thing. Because this needs to be doing pause 2. If at second. And now that I'm doing my hack, we also have to do plus 4. But why is this one now slow, but the other one isn't? It can't be that I would fix it by coming out barrier, because barrier should be a no-op, because I plan to find it away. In fact, we can just not call generate visibility. Or it can disable it. Okay, that's disabled. We won't see anything. 31 milliseconds. Return back on barrier. Shouldn't make any difference because it should be commented out. 37. Enable this, and it slows back down again. Same speed, even if we skip data. I'm just so confused. I'm so confused what is happening here. Yes, because there was a lot of GPU compute programming 45 years ago using a 25-year-old compiler. Why? I gotta give up. I'm so confused. I don't understand anything that's happening here. I took out barriers and it got... I took out barriers. Okay. when we were at 8, define hack half else def hack half. So then where did I do this? Okay. If def hack half else pause minus equals region. If def hack half enable it. Go back to the where we were before. Some hack is still on. Something is still broken that I changed. Or did I never have this working? When I copied the list over. I thought I had it working. Am I skipping? Okay, let's get visibility old. Why do people do dumb drive-by questions? Like ask a question and then immediately leave without waiting for the answer? I mean, I know why. It's the same reason why people post comments on YouTube. They think they are supposed to say something, even though they're not interested in having a conversation or communicating. They just think they should express their opinion. And they choose to express their opinion as a question for no apparent reason. That looks like missing barriers. Oh, because we... Yeah. If we have hack half, we disable barriers. Okay. So now that the barriers are back. Nope, that's not it. Do I still have something hacked in somewhere? That goes region. I don't think I've changed anything. Change visibility old. Oh, yep, you're correct. Thank you. Okay. And it only took 0.59, which is more than 0.44, but whatever. So that way works. Then we go to split jobs, which is not as fast as I was hoping. Now it is. Oh, now we're back to the 4.9 milliseconds. We had been stuck at okay, we're still doing a barrier here. We're still doing all the barriers, and it's back to 0.4 whatever. When it had gotten bigger, I think. And I didn't know why it had gotten bigger. And then if we actually split, same time. Oh, it's not correct anymore, right? Oh, no, it is. Okay, so we are splitting the lists, I think. We're splitting the lists let's do 8. And let's say split equals gl local invocation id.x and 7. Let's use a totally different method to assign it. Okay. So we assign them all to different things. Then we go over all the lists. Yeah, who knows? Yeah, who knows why that timing was bad. Okay, now if I got rid of the barriers, it'll be garbage. Am I running the one I think oh, no, I'm running old. That's why. I changed that and not that. Now we'll get the old behavior. Okay. Barrier. Okay, and now we get the slow behavior. So we don't call generate visibility. And it's the good time. But if we do this barrier, we get the slow time. Yes. Okay. We're back to where we were before. Now, the question is, what results do we get if we don't do the barrier? We'll get garbage, because we need to do the barrier. Or we don't get garbage. I think that's just dumb luck that we didn't get garbage. But we're also, wait, oh, no, we still got the slow time. So somebody doing a barrier? No. I mean, this one is, but we definitely get garbage without that. What is happening? Okay, now we got garbage, though. Why is it slow? Why is this one fast? Why is this one fast and this one slow? When the whole point of this was to try to speed up this. We wanted to try to make it go fast in 0.49 milliseconds by first splitting the jobs and then generating visibility. Okay, the split jobs does not slow it down too much. But the new generate visibility does. Probably because it's iterating over so many lists. Wait, no, it's not. Is that just because of this? No. Wait, what? So what did I change? Oh, I'm running the wrong one again. Dang it. I keep making this, changing the wrong thing. I keep futzing here when I do that. Okay, there. We're using the new thing again. And it's slow, yes. Turn off the barriers. So many mistakes. That barrier doesn't help. That barrier doesn't help. We switch it to using old visibility. also slow. So make split job seems like it's slow. Slow down the timeout, or speed up the timeout in case it's that. Only process one list. Disable this step. Enable this step without a barrier. Now it's slow. Enable the barrier. It's even slower. All of this is so much slower than generate visibility old. I do not understand. I mean, I did say that I kind of need to merge this. Globally, so that we can go across work groups for actual optimality. But all right, let's make the split jobs. Now it's going to store a UVec4 split job storage, split job. It's going to be a UVec4 now. This becomes make split jobs local. Make split jobs non-local. Needs to take a barrier. Needs to compute unit is south equals south, unit is east and west equals unit is up down equals down and up. And now our new job, UVec4 job, oh, we need 5. Ugh. Oh, no, 4 is enough. 4 is enough. UVec4 job 4 equals UVec4 of job. No, we do need 4. We need to store V. Store is S viz EW viz UD. Oh, we can store V and that. That works. Job 4. Let's make split jobs. Split jobs. Let's see what errors we have in that. You went to UVec and 351 and 377. Yeah. That old code. The old split job code has to get zeroed out. .57 milliseconds. So not any faster than the old visibility generator. So yeah, I don't know. It doesn't seem like there's a good way to go from this data Wait, now we're only computing occupancy, and it's still the 0.57. I think OBS is fucking with me a little bit there. Hack half is disabled. We didn't end up using this. That's just optimizing it out, potentially. So we want to run the atomic add. Although technically you could still optimize it out. Yeah, that still goes up to 0.57. So just doing the atomic add puts it up to 0.57. But then if we run generate visibility old, it's about the same. Oh, except we did break it. Oh, because that's disabled. Right, yeah. So if we disable this and disable generate visibility old, get 0.56. But if we enable generate visibility and enable this, we get a smaller number. Doing more work, we get a smaller number. That definitely makes sense. Yeah, it's some old driver, whatever the last supported one for this hardware is. It's a 980, a 980 Ti. Yeah, to do it more locally without barriers, we just tried that. Well, that's the hack half thing up here, where it defines barrier out and runs on a smaller work group size, and was not an improvement. I mean, as I've said, we can ship it if it takes 2 milliseconds. We can still ship it by splitting that work up over multiple frames. I just wish I understood why this doesn't work. And why it gets faster when I do more work. Because if I don't do the more work, it ought to just be able to optimize a lot of it out, I think. Maybe not. Maybe because I intentionally made sure I did that. Well, that's been another 2 hours, and I think that's maybe all we're going to do. Just does not help. And I don't know why. Why is the texture not mip-mapping? Or is it mip-mapping? It's just still aliasy. I think it's not mip-mapping. Main. Texture. Somehow I disabled this at some point. Oh wait, there was another call right below it. Oh, it was just because the texture filter had it disabled. Well, no, it's still... Oh, that's actually geometric. That's geometric aliasing because those are also tiny quads. We would need to turn on MSAA, which I can't do directly. I have to actually render to a render target, and I don't want to do that work right now. Yeah, I don't know what's going on here, but spent 2 hours trying to figure it out. Maybe I'll think of a different strategy to go from sparse to dense. Yeah, like, so what I wanted to do was just write out the data to memory, the sparse-ish data to memory, which is here. We just always write it out. If voxels is greater than 0, we write out exactly one piece of data. And then we could come back in a separate pass and structure it differently. But But this is not faster. Calling make split jobs is not faster. .58. It's 0.58, so like might as well just build the voxels rather than output the split jobs. We could try to merge the atomic add. Use it with the ballot. But I doubt that that's going to be it. Yeah, doesn't make any difference. All right, so that's it. Any questions before I end the stream? I guess not. Stupid idea. Which subgroup data atomic add of 1248? Then you have to busy wait on that atomic add, which is just going to be worse. I'm busy waiting for the neighbors to be ready. All right. Thanks for watching. See ya.